So here we have just the wires for the 4-player 1D Pong. Now it's 4 players because it has 4 LED strips. So it has 6 LEDs on each strip, and then we've got a button for each strip. So I've got 1, 2, 3, and a 4th button here. So the way all of that is done, and this is very, very messy, but it works, and this is prototyping. I have a common ground. This whole knot of wires is a common ground, and I have a common power. So here on my board, so the common ground here and a common power, and this V out gives 5 volts. So normally you'd only be able to get 3.3 volts out of the CircuitPlayground, but as long as you have a 5-volt input source, so if you're doing it from a USB, then you can use the common V out and get 5 volts, which is enough to drive your NeoPixels. So each of the NeoPixel strips has a ground, a data in, and a voltage in. The voltage in is 5 volts. It also has a voltage out. Now I had a small problem because I wanted to play sound on here. The A0 pin is also the audio pin. I needed 8 pins, 4 for the buttons and 4 for the LEDs. And that was all I had available, which required that I used A0. And the problem with that was then I couldn't also play sound. So the way I had to change that is now the data out on each of my LED pins goes to the next one. So my strip 0, or strip ID 0, the first strip, player 1, goes to 2, goes to 3, goes to 4, and then 4 is just set as is. So when it comes to wiring, I used a small number 3 size screw, and I just stripped so that way I can easily take things on and off. And the only things I needed was I needed the buttons, so the buttons go into all of the odd ones. So A1, A3, A5, and A7 are getting the buttons. And then all of my NeoPixels are being driven out of, I believe it's 6, right here. And as I said, all of them are getting power through the common power, and they're getting grounded through the common ground. Everything else is done through code. And I'm going to make this nice and put it into a case, and then I will show off the code. So here is the fully assembled 4-player 1D Pong. So this is what happens. In this case, I had 2 players. So this one was red. That means they lost, and this one was green. So that means they won. So as you're playing, you have a certain number of lives. And when you lose all those lives, your row becomes red. And so I will hit the reset button. So our indicator is going to go around, and this is saying that we are in getting ready mode. And at this point, any set of players can come in or out of the game by pressing their button. In this case, I'll just play 2 players. So when you're ready, you press any of the 2 buttons in the middle. And now we're in actual play mode. Now it's a little slow, so I'll speed this up. But you have to press the button right as the last pixel lights up. And if you do, you hear the success sound. Now, sadly, the playing is synchronous, so you hear the sound and then things move on. A little bit of a delay. But I will now fast forward, and you'll see what happens when I lose. So this is going to go all around. It's going to skip the other strips. It's going to go down again. And then it gives you an eep. So we're going to fast forward. And we're going to see what happens after you lose all of your lives. So this one is going to lose first because it was the first one that I didn't hit. So when it got back to the middle, it did a check and checked and said this had no more lives, so it made that red, and there's only 1 player left, so that player became a 6. I do want to note, after every successful hit, the ball goes a little bit faster. I'm up to the maximum speed where there's a delay of only about 0.03 seconds after all the code runs. So it actually moves pretty darn fast at that point. This is running with a CircuitPlayground Express in there. And I have all the wires screwed in here. I probably want to come up with better prongs because every once in a while a few strands will get out and then they kind of can touch other things and it causes the buttons to get a little wonky. But ultimately everything's coming here through the common ground, the common voltage, and then I've got all A1 is running all the strips. Then I've got 0, 2, 4, and 6, which are running the buttons. And because I didn't have enough options for inputs and outputs, I'm running each strip down, and then that strip, the data out, is coming back in and going out to the next strip. And that goes all the way around until we have the last strip, which has nothing in it because that's the terminal at the end. So that's how that works. Now, this was a takeout box that I got. Food came in it, and it happened to just be the perfect size. And I did change it 1, 2, 3, 4, 5, 6 LEDs. I originally wanted 10. 10 was kind of too much. Maybe if they were a little closer together, that would have worked. But I think this works pretty well. If I flip this over, you get to see the mess of wires. I only had red wires, so that's kind of all I could choose. But this is how it is. I mounted everything here. You can see two different screws, which I used to mount. See in there. So I have 2 screws that are mounting this on. I probably could have mounted more. This is just a prototype, and if I wanted to make this more production ready, I would have really nice mounts going here. I would have a little PCB that controls all that. These wires would feed right back down in, and everything would look a lot nicer. But for prototyping and getting something up and running, I'm really happy with how this turned out. And let's jump into the code. So let's walk through the code. Now, I'm not going to walk through how to use Python or necessarily CircuitPython, which is this, but I'm going to walk through the logic. I will at some point be doing a tutorial on getting started with CircuitPython and what everything means, but that will allow me to skip through and be really quick here. All this code will be available on GitHub, and there will be links below in the description to the repository, so you can download this code and play with it as is, and build this yourself if you'd like. So here we have our imports. We're using the CircuitPlayground Express library, which is just basically some really nice shorthand to get started really quick using the CircuitPlayground Express. We're using analog in, the NeoPixels, and board and time. We are assigning our 4 buttons. Now in this case, I'm creating the buttons here and later on putting them in an array, and that allows me to easily create them, but I'm binding the buttons to analog 1, 3, 5, and 7. I'm playing a sound, so as you see here, the CircuitPlayground Express library makes it just nice and quick, so it's just cpx.playFile, and that plays a sound when the game starts up. Assigning middle pixels, which is this CPX, the CircuitPlayground Express's pixels, and setting the brightness to 0.2. Setting the number of pixels on each of our strip. So this allows it so that if you build the game with 10 pixels or 4 pixels or something more or less, you can just change this number and the rest of the code will work. So then we have our pixel strip. So our pixel strip, it's one giant strip of pixels for the 4 different players. So this is set up in the code as such. So it's one giant NeoPixel strip with 4 times the number of pixels. And then the brightness is 0.1, so it's not very bright, and the auto ray is false. I set up my button array of 0, 1, 2, and 3. I have some predefined colors, which just help make it a little bit neater later on. We have a buttons pressed and a buttons previous state. Now there are some libraries for using buttons with digital in where you can check if they are pressed or not. But what I really wanted is I wanted that first instance that something was pressed. I didn't want it so that the user could just hold the button down and then always win. I wanted it so they had to press the button during that frame that the ball was in. So the way I did this is I have an array which says whether or not the button was pressed, true or false, and that uses a previous state. So it checks the previous state and its current state and sees if that state has changed into a positive way or a negative way to determine if things were pressed. We have the fails, which really could just be called lives if you wanted to be a little more positive about it, but I was thinking about the amount of times the user has missed. We have our ball location, which is a 2-dimensional array. So the first item in the array is which strip it's on, so which line, so which player. So it's player 0, 1, 2, or 3. 4 is the circle in the middle. And then position 0 is what pixel it is on there. So for the 4th strip, there's 10 pixels around, so 0 to 9. And on each of the individual strips, there's going to be 0 to 5, which is the 6. Then we have a ball direction. So this is key in any game of Pong. So if you're doing 2D Pong, like that standard Pong, you have a ball X and a ball Y direction. And those are usually positive or negative numbers, and that determines is the ball going to move in a plus X direction or a minus X direction. And then the larger or smaller that number is affects the speed. So in this case, the speed is controlled by the loop mechanism, and the ball direction is either positive or negative. We only need to have one direction because it's one-dimensional. We have our active players, which is a multi-dimensional array with false, 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 because all the players start not in the game. And when they press the button, we add them to that. We have our game state, which is just a variable to what state the game is in. So 0 means the game is just starting, waiting for players. Then 1 is the game is active and the game runs through its normal loop. And then 2 means the game is over and display who won. We have our loop delay and our active loop. So the loop delay says how many loops do we want to go through before we display the next animation. So the game is going to get faster because the loop delay gets lower. And the active loop is really just a counter to see how close we are to that delay. And we'll talk about that when we get into the main loop. So we're still initializing everything. So I take the middle pixels and I fill them as black and then show. And then I do pixels, fill black, and then show. And this turns everything, it basically erases and clears the previous game. Now we have a mapping. So we have a strip to the button because we want the buttons to line up with the strips that are out there. Now, originally I had everything lined up so that they were all different pins, but I had to rework that. So the LEDs were a single pin. So I had to note that button 0 was player 2, button 1 was 4, button 2 was 7, and button 3 was 9. So I just kind of had to switch those to 2, 7, 4, 9. So this is how I had to swap them. So this basically just tells me what pixel. Because on the ring, what I wanted is in my CircuitPlayground ring, I wanted the pixels as it went around. When it got to the pixel that was closest to the LED strip, it lights up. So this is how that mapping works. So player 0 is at pixel 2, player 2 is at pixel 7, and then 4 and 9. And my last strip was -1. This is a placeholder, and this says whether or not the ball was either on a strip or is in the middle. We can use there. And then we have pressed correct, which is very similar to our pressed and whether or not they've done it in a correct fashion. And again, it's just a multi-dimensional array so that we know which player has pressed when. So now we get into the meat and the logic. So we have a function here, fill strip. And what fill strip will do is there is already a function called fill. And what fill will do is it will take all of the pixels within a neopixel strip, give them all that color, and then you do .show, and it will show them. But the problem is I have virtual strips. So each of my strips is just a section of a larger strip. So in here, I'm taking fill strip, my index, and then my color, and then I'm determining what is my start and end offset, which is just my index times my number of pixels, and then the index times number of pixels plus number of pixels. And then setting each one of those to whatever the color I want is, and then it updates all the pixels so that they display. I have a similar function for set pixel, and this allows me to set pixels based off the array. So my original code had everything on an individual pin. So I was just saying, do strip 0 position 2. And in this case, strip 0 position 2 just needs to get translated. So my index times my number of pixels plus my pixel, and then it updates the strip. So now we have our loop. So this is the main game loop, and it starts here with while true and ends all the way down with a time.sleep. Now, the quicker you make this, the faster the game will be. So right now, at the end of every loop, it's going to delay by 0.03 seconds. So if you want the game to go super fast, you could actually just reduce this. I had the game going at a medium speed, and I gave it 20 loops, and then each time the button is correctly pressed, then the loop speeds up because it goes 19 loops, then 18 loops, and 17 loops before it actually does something. So let's go through the logic. So our active loop increases, and then we check to see if our active loop is greater than our loop delay, just set it back to 0. So ultimately, active loop is going to go through 0, 1, 2, 3, 4, 5, up to loop delay, and then back to 0, and then back to 0. This is just a counter so that we know when to be doing our animations. Then we check each button, and we check it for its button state. So if the previous state for a button was less than 1,000. So with the buttons I have set up, and the way they're analog input, the analog value of off or unpressed is somewhere less than about 200. But I wanted to be really fair and safe here, so I did somewhere less than 1,000. And then my button press is somewhere above 11,000, so I gave myself a little buffer here and said about 9,000. And this should factor in for anything else that might cause the resistance or the value to change. So if my previous state was less than 1,000, which is off, and my current state is greater than 9,000, then my button pressed is true. Otherwise, my button pressed is false. So what this means is my button press will only ever be true for 0.03 seconds, and then it goes false. So that way, if I hold the button down, it's going to go back to false on the next frame, because the next frame, then the previous value will not be less than 1,000. So this way, it's kind of a little bit of anti-cheating. So the button previous state is my current button value. So it's basically saying, make sure to set the previous value to whatever it is now so that we can loop and iterate. Now we have our game state. So our game state, as I said, we have 3 different states. So I have game state 0, 1, and 2. So for game state 0, what I'm going to do is I'm going to check for the CircuitPlayground button A or button B. So those are the 2 buttons in the middle. And if either of those is pressed, I want the game to start. So it's going to set my game state to 1, my active loop to 0. So it's going to give us a full chance before the animation starts. And then it's going to reset all the active players to having black. So when a user joins the game, it makes their strip green to show that they're active. But we don't want to leave it green while they're playing. So that's what it sets it back. So if our active loop equals our loop delay, so this allows us to show our animation. So in this case, we're taking the middle pixels, because in the early stage game, all we're showing is the animations in the middle. So we're taking our middle pixels, the ball location 1. So ball location, remember, is 2-dimensional array. So the first dimension is where it is. And in this case, we know it's in the middle. And the second one, so position 1, is going to be its position within there. So pixel 0 to 9. So we're going to set the current position to black, increase the position, so move to the next position, and then make sure it's not looped. So make sure it's not over 9, so protection, because if it's 10, that's not a valid pixel anymore. And then set the new pixel to white. So really all it's doing is moving. So set the current one to black, move it 1, set the new one to white. So that way, turns one off, turns the next one on. Now we check to see if someone joins the game. So going through each of the buttons and checking their indexes. So if a button is pressed, then we take the active player, and their index is not the active player index. So that means if they are active, then we want to make them false. And if they're not active, we want to make them true. And then we check and see if they are active, make them green. If they're not active, make them black. So that allows someone, so let's say you want to play a 4-player game with just 2 people, and then you realize, hey, that's too hard. You can easily press a button and leave the game. So that's all that is in the kind of waiting stage for letting people join. So then we get to game state 1. This is the active gameplay. So this is going to look very similar, and there's a lot of comments in here, so I'm going to run through this a little bit quicker. So it's going to check each button to see if the button is pressed. So if the button is pressed, then we're going to check if the ball location is 0 and the ball location 1 is number of pixels minus 1. So our number of pixels is 6, which means there's 6 pixels on there, which means the last pixel is pixel 5, because we go 0, 1, 2, 3, 4, 5. So if our index, so meaning if the person who pressed the button is the same position as the strip where the ball is, which is ball location 0, and the ball location is on the last pixel, then pressed correct equals true. Now, I don't have anything in here so that if you press it at the wrong time, that you're penalized. You can always add that in yourself, but more I wanted to reinforce positive and pressing the button at the right time. So this just determines if the button is pressed correctly. So then we check if active loop equals loop delay. So this is going to be our animation. So if the ball location 0, so this is what strip it is, equals 4, then we're in the middle section. So in this case, we are actually going to check now. So we're going to check to see if any players have lost, and if they have, we're going to set them as red and then take them out of the game. So set the active players index to false. Then we're going to check how many players are still alive, and if only one player is still alive, we're going to win the game. We're going to play fanfare, we're going to light that player up as green, and then we're going to set the game state as 2, which is completed. If our last strip is greater than -1. So originally I said we set this to -1, and the reason for that was the ball never starts on a player's strip. The ball starts in the middle. But if the ball is leaving someone else's strip, then what we need to do is we need to make sure we unset that pixel, otherwise it's going to remain lit. It's going to remain white. So if that's the case, then we set the last pixel to black. So our middle pixel's ball location is black. Then we move the ball location. If the ball location is greater than 9, we turn it back, and then we met the next one as white. So this is for ball location 4, which is the middle. So it's the same animation sequence we had in the beginning. It's just going to go around the pixel circle, adding 1 until it hits 9, and then going back. Then we're going to check and say, hey, if our current location is our hopping point, meaning the pixel in which we want to jump onto the next person's strip. So here we're going to go through each of the players in the active player list, see if they're active, and see if the ball location, so the strip location, is the same as the location map. And if it is, then that's where the ball is going to go. So the ball location is going to be set to the index, and the ball location 1 is going to be -1. The reason why this is -1 is because as part of our loop, we are going to add 1 to the display. So what we're going to do is when you add 1 to -1, it becomes 0, which is the first position in. So this is basically setting it as negative position so that the first position displays. So then we have an else, and the else basically says any strip. So the first up here, what we're ifing is the ball location 4. So that means, so now the loop is if we're in ball location 0, 1, 2, or 3, which is any of the active player strips. So again, all of this is in comments if you're kind of a little bit lost following this. So if ball location 1 is -1, so this means that it was first starting on the strip. So if so, we're going to unset the middle pixel ball location. Otherwise, we're going to unset the ball location on our current strip. So we, again, like all the other animations, we have to set the current pixel to black and the next pixel to white. So we set this as black. We move the ball, so ball location plus equals ball direction times 1. So you could make this move 2, you could make this move 10, you can do a lot of different things. This is more just following standard logic of how to do this sort of animation. So in this case, we're either moving up the strip or down the strip based off the ball direction. And then we set the next pixel to what it should be. We check the ball direction to see if it's equal to the num pixels -1, so in this case 5, and that's the end of the strip. What we're saying is if the ball has moved all the way to the end of the strip, we want to change its direction, because if we keep moving, it'll go off the strip, break, or technically it'll display onto the next strip, but that isn't what we want. We want it to reverse direction and go back to the middle. So the way we do that is we set the ball direction to -1. So now what we need to do is we need to see if the button was pressed correctly. So what we're checking for here is if the ball direction is num pixels -2. Now, why -2? Well, the reason is the last pixel is -1. So our number of pixels is 6. So 6, since we're starting at 0, so our last pixel 0, 1, 2, 3, 4, 5. So our last pixel is going to be 5. And then when it moves backward, the next one is going to be 4. So we want to check. So we want to give the user one full animation sequence to press the button. And the only way we can do that is when the next animation sequence starts. So we're checking that the num pixels -2, so it's position 4 in our case, and the ball direction is -1. So again, it had to have already started turning around. So here we check, did they press the button correctly? If so, we play the file coin, then pressed correct is false. So we remove this so that it's not always correct, so they have to press it again the next time. Then if the loop delay is greater than 1, then we set the loop delay -=1. So our loop delay starts at 20. So if you're correct, then loop delay becomes 19, and then 18 and 17. So less loops happen before the animation plays, which makes everything look a whole lot faster. And if the person didn't press the button correctly, then we play the file wild eep, eep, and then it adds to the fails. So fails of the ball location 0 plus equals 1. Then finally, if ball location 1 is equal to 0 and ball direction is -1, so this means that the ball is traveling back towards the center and it's on the last pixel, then what we want to do is the ball location 1 is the location map. So we're going to set the pixel in the middle equal to the mapping in the middle so that it looks like the ball is going back to the right position in the circle. Our last strip is going to be whatever our ball location 1 is. The ball location 0 is going to be 4. So we're going to say that, hey, the ball is now in the middle, and our ball direction is going to be positive. Now, in the future, I had some ideas about having it so whenever it goes in, it goes a random direction of left or right. That way you can kind of, especially in a 4-player or 3-player game, it keeps people really on their toes. But I didn't feel like programming that in to start. I wanted to keep it simple and get it out there. So that's all the logic. I tried to keep it as basic as possible. There's still kind of a lot of high-level stuff going on here, but I kept it as compact as I possibly could. A lot of things are easily played with. You can easily change the delay. You can change your loops. You can change the logic really easily, but all of this is available in the GitHub, and you can check it below. And I really hope you liked this video. If you found it useful, check out my other videos. Feel free to like and subscribe and do all that wonderful stuff. And if you have any questions, ask them in the comments, and thank you so much.